So in this video, I'm going to show you how to draw a ray diagram that can tell you from an object where the image is. So I've got this set up already with the laser and the mirror. So the mirror is here, and you can see all the parallel rays come in. They come down to one point, so I know the focal point F is there. The center point C is twice that distance, so I've drawn the center point C there. I've put an object in here, so I just drew my object as an arrow pointing up. It could be anything at all. You can draw an elephant or a person or a house or whatever you want. An arrow is a nice simple thing that I can tell which end is the top and which end is the bottom in my object. And then I have the principal axis. So I used the laser along with this to be able to draw this so it's all correct. This is what I would expect it to look like for you, that if you were assigned the problem of drawing a mirror with a focal length of whatever, you would just put everything here in roughly these positions. And now you can see I drew in a dotted line for the principal axis. So if a laser beam came in along this line, it bounces back straight along that same line. So that's the principal axis. The focal point and the center are both on the principal axis. And then I drew the object. So the object also is standing on the principal axis. That's just more convenient because it means that the image of the bottom also will be somewhere on the principal axis. I don't need to worry about it. I can just worry about the top one. So then what I have to do is I can draw one of three principal rays that go through this object. So if you remember, one of the principal rays is the one that goes through the focal point, because then it comes straight back parallel. So I'm going to take this laser, draw a line through that goes through the focal point, and you can see it comes back parallel to the principal axis. So one of my principal lines, this is the focal one. The focal line comes in and does this. So this is the focal. So for you drawing it, you don't have a real laser and a real mirror. So just draw a line from the object straight through the focal point F, hit the mirror, and then when it hits the mirror, draw it coming parallel to the principal axis. So that's one of the lines. That's the focal line. One of the lines was the center line. If I draw through the center, it should bounce straight back. So if I do that with my real laser, okay, you can see I missed the mirror entirely. Okay, so that makes it not a great one to choose from. Remember, I showed you three and said sometimes two of them are going to be easier than the other ones. So in this case, it's easier to not use that one. So the center one, we're going to skip for now. And instead, we'll do the parallel. So the parallel one goes in parallel to the principal axis and then comes out, I've got to get it. Not always terribly easy to draw. Okay, so the parallel one comes in parallel, bounces off and goes through the focal point. So through the focal point will be down here somewhere. Okay, so the focal went this way, the parallel went that way, and you can see we've got a place where they cross. So we know our image, the top of our image, is going to be somewhere right about there, and the bottom will be up here. So that's how you draw the image. And remember I said we were going to skip the C one because it was actually going off the mirror? Actually, as it turns out, we could have used it. Because if we go from the top of the object through the C, it also hits it. Even though our mirror is too small, so no light's actually coming down here and bouncing off, you can still use that one. So that was the focal line, the parallel line. Oh, I can't remember what this one was called. Is it called the center line? Whatever it was called. At any rate, any two of those three is enough. And again, there's an infinite number that you could possibly draw. It's just these are the three that are easiest. Okay, so that's how you find the position of the image. So in this case, the image is inverted, flipped upside down. It is reduced, so it was big, now it's small. So it's inverted, it is reduced, and it's a real image because, well, you saw the laser beams. The laser beams came from here went through and actually got to that place. So I know it's a real image.